Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at another student question. Particularly we're going to be focused on solving a linear system of equations using a matrix. Okay, so this following question here has been given. So consider the pair of linear equations shown. So we see we have two linear lines. Now with a linear line we know they look something like this, and we can see their gradients aren't the same. So we're going to have a scenario. Now their gradients aren't the same and different things here, but now we know we're going to have a intersection point somewhere. Okay, now you could solve these using simultaneous equations using substitution or elimination. However, specifically we need to solve this using matrices. Okay, but we know we do have a scenario where pretty much these lines are going to have a common point x and y where they both pretty much share that same value. Okay, so now this question set up quite nicely, just pretty much to show you how to pretty much do it. Okay, so here transpose the equation so they're in this form here. Now the reason why we're doing this is because if they're in that form there, then it's really easy to convert it to a matrix then. Okay, so here we'll just consider these lines here. Now what I'm going to do first is I'm going to change that number to a fraction, because for me working with a fraction is a lot easier than working with a decimal. Okay, and that fraction is going to not be too bad. Okay, so here we have the first equation, so y equals 2x minus 5, and if we want to put it into this form here, obviously we need to move the 2x across. Okay, so move the 2x across, minus on both sides, so we'll have pretty much negative 2x plus y equals negative 5. Okay, now let's take a look at this equation here. So I'm going to rewrite negative 1.5 is the same as negative 3 on 2. So here y equals negative 3 on 2 x plus 2. To write it like this form here in the orange, I've got to move this term across. So it's going to be 3 on 2 x plus y equals positive 2. Okay, now we can see here we've got both of these guys transposed into this form here. Okay, now show the equations in matrix form. Now this is where you need to have a good understanding of how a matrix works. Okay, so we can write this as a matrix using the common idea that if you're multiplying two matrices, you go row times column. Okay, so for example, if we're saying we have a 2 by 2 and a 2 by 1, so let's say we have a 2 by 2 and a 2 by 1, we can multiply these matrices because the columns of this matrix match the rows of this matrix here. So it would be this, so row times column gives you that output, and we can work out what the answer would be. So this would be a 2 by 1 here. Okay, so here what we're going to do is we're going to rewrite the left hand side as a product of two matrices. So we're going to write it as a 2 by 2 and a 2 by 1. Okay, now what it's going to be on this side here is going to be the coefficients of these numbers here. So this first equation will be my top row. Now just the coefficients, so negative 2 will go here, 1 will go here, and then these ones would go on the bottom row. So 3 on 2 would go here, and then 1 would go here. Now what would go in this matrix would be x and y. Now the reason why for this, if we did row times columns again, if I multiply this row by this column, it will produce this what's it called, top equation. And if I also did row times column, this will also produce that guy there. So this is still exactly the same mathematically as these two here, pretty much. Okay, now this side here we can just write this as negative 5 and 2. Okay, so hopefully you can see how I've gone from that in this setup here to this form here. So all we've done is gone from a linear system with two lines to now a matrix where we have the information stored into one. Now what we've got to do now is we've got to pretty much solve for x and y, because remember we're looking for an x and y coordinate, but we've got the following set up like this. So we have ax equals b, where this is pretty much my A matrix, this is my x, and this is my b. Okay, now if we want to get x by itself, to find out what x and y are, we need to multiply both sides by the inverse of a. So if I multiply both sides by the inverse of a, it's going to cancel out on this side, and we're going to get a matrix C on this side here. So x will be A inverse times by b. Okay, so pretty much in simple terms, we need to find the inverse of this matrix here in order to work out what we're doing. Okay, so pretty much the first thing to do is just label it. Okay, so go A equals negative 2, 1, 3 on 2, and 1. Okay, now if you're finding the inverse, let's say you have A is A, B, C, D. If you find the inverse of a matrix, it'll be 1 over the determinant of this matrix, so it'll be AD minus BC, and then it would be D, negative B, negative C, A, okay? So we change the sign of these two guys here, and we swap the A and D around, okay? So in our setup here, you can clearly see that is going to be your A, that is going to be your B, and vice versa, okay? So all we're going to do is just plug this matrix into this formula here. So A inverse is going to be 1 over A times by D, so negative 2 times 1, subtract 1 times by 3 on 2, okay? Then we're going to pretty much swap these terms around because that's my A and my D, but in this formula here we have the D and the A here. So this will be 1, that will be negative 2, and then we're just going to flip the signs of these two here. So we have negative 1 and negative 3 on 2, okay? We could probably simplify this a little bit more, but A inverse should be a slightly uglier matrix than the first one. So here that's going to be negative 2, and that's going to be negative 3 on 2. So we have 1 and then negative 2 minus 3 on 2, okay? You could probably combine it using fractions, but I'm going to be lazy and use a calculator. So minus 2 minus 3 on 2. So it's going to be negative 7 on 2 on the bottom, okay? So here, because this turns into negative 2 minus 3 on 2, because that's negative 7 on 2, 1 over that is the same as this turned upside down, so negative 2 on 7, okay? So I'm just going to rewrite the front bit like this. So as negative 2 on 7, and then I'm going to have this matrix here, negative 1, negative 1, negative 3 on 2, and negative 2, okay? Righto. Now we've got our inverse matrix, we can now pretty much solve the system we had above, okay? So keep this matrix here. I'm just going to move all this working down. Let's go here. So go copy. Oh, what am I doing? I can what's it called? Select it like this. There we go. All right. So at the moment we have it as A, B, A, X, and B. So if you want X by itself, it will be A inverse times by B. Okay. So here X is your matrix X and Y. So XY will be equal to this matrix C. So this is because this is our inverse matrix C of A multiplied by B. Okay. Now the reason why we can multiply this matrix is because look at the sizes. Okay. So remember your columns and rows of the specific matrices have to match. So let's see if they match here. Okay. So this is a 2 by 2 and this is a 2 by 1. We can clearly see they match there. Okay. Now we can also see our answer is going to be a 2 by 1. Okay. So the way we do it, I'd probably multiply that number out. So here I would have X, Y, and then this would be negative 2 on 7. This one would be positive 2 on 7. This one here, oh, I'll probably use my calculator because I'm going to be lazy. So negative 2 on 7 times by negative 3 on 2. Alright, 3 on 7. And then, oh yeah, you could cancel the 2s. My bad. This number times negative 2 will be positive 4 on 7. So that matrix C still times by this, so negative 5 and 2. Then you just go row times column, okay? So this row times by that column will give you your first output here, okay? So here it'd be negative 2 on 7 times by negative 5 plus 2 on 7. And I'll move it across because we're running out of room. 2 on 7 times by 2, okay? So that's your first, that's going to be your X coordinate, okay? Then you now go row, the second row, times the column again, okay? So it'll be, 3 on 7 times by negative 5 plus 4 on 7 times by 2, okay? So let's just chuck this into a calculator. So the first one, negative 2 on 7 times by negative 5 plus 2 on 7 times by 2. So that answer, that top one, actually simplifies to 2. This guy here, so let's go 3 on 7 times by negative 5 plus 4 on 7 times by 2. It's going to give you negative 1, okay? So this is what x, y equals. So x, y equals 2, negative 1. So that means this system has a common point at, what's it called? Oh, I forgot the coordinate. It's 2, negative 1. 2, negative 1, okay? And we can double check this as well. So, if we substitute the values in, so let's substitute both of them into each equation, you should have left hand side equals right hand side, okay? So in this case here, we could probably use a graphing tool if you wanted to in this case here, but I would just sub the point in here. So if I go, let's just chuck in, so if I chuck in the x value into here, so I have y equals 2 times by 2 minus 5, and then here I have y equals negative 3 on 2 times 2 plus 2. That one would simplify to negative 1. And then this one here would be y equals negative 3 plus 2 would also simplify to negative 1. So we can see they both have that point in common, okay? I just realized I didn't read the back bit of the question. Use the matrices to solve blah, blah, blah. Okay, well that's how you solve it using matrices, so it was answered anyway, okay? But the trickiest thing is going pretty much from this form here in the pink to this guy here, okay? Once you've got that, it's pretty just sweet from there, okay? But again, that's quite hard if you're first doing it, okay? If you have any major questions about this question, leave something in the comments, but otherwise I'll see you in the next video.